Hey everyone, welcome to this tutorial on the basic differentiation rules, your toolkit for finding derivatives quickly and accurately. By the end of this video, you'll be able to differentiate functions such as x cubed, 5, or even 4x squared minus rad x with confidence. You may ask yourself, why do we care about derivatives? Well, imagine you're driving a car. Your speedometer shows your instantaneous speed. That is a derivative of your position over time. Today, we'll learn the rules that make these calculations effortless. So, our rules for today. 1. The power rule. Use this for functions such as x to the power of n, or whenever there's an exponent. Constant rule. Use this for standalone numbers, so numbers that are not accompanied by a variable. And 3. The sum rule. Use this for sums/differences of functions. Alright, let's go over the power rule. The power rule is going to be your best friend for polynomials. Here's the mantra. Bring the exponent down, then subtract 1 from the power. Let's take a look at our example. F of x equals x squared. Now, let's take the derivative of both sides, so the derivative of f of x and the derivative of x squared. Then, we'll drop down the 2 from the exponent, so we get 2x. Now we have to subtract 1 from our previous exponent, so that'll be 2 minus 1. The resulting number will be 2x to the power of 1, also known as 2x. Try this example. What is the derivative of x to the negative power of 3? Alright, our first step here is to bring the 3 down, so we get negative 3x. Then we're going to want to subtract 1 from the negative 3. Negative 3 minus 1 is negative 4, so the answer for the derivative of x to the negative power of 3 is negative 3x to the power of negative 4. Here's a pro tip for the power rule. You're going to want to rewrite roots and fractions as exponents first. For example, square root of x, that's equivalent to x to the power of 1/2. This will make it easier to use the power rule. Another example is 1 over x, which is equivalent to the x to the power of negative 1. Alright, here I have a tricky example. I want you to try this on your own, and I'll reveal the answer in a bit. So here's the work. The first step you want to do is rewrite cubed root of x squared as x to the power of 2/3. From here it becomes simple. You want to drop down the 2/3 in front of the x, and then subtract 1 from the exponent. So 2/3 minus 3/3. That gets 2/3 times x to the power of negative 1/3. Next we'll be covering the constant rule. In calculus, constants are flat lines. If f of x equals 5, the resulting graph is a horizontal line with no change and no slope, so the derivative of f of x equals 0. Any and all constants are included, including pi, 40, 50, and even e. Another way to think of it, if you're not moving, then your speed is 0. Let's try some examples. If f of x equals 10, then what is f prime of x? The answer is 0, because since there is no variable accompanying the 10, it is considered a constant, and the derivative of a constant is always 0. Next, f of x equals 20e. What is f prime of x? The answer is also 0. Although it may look like a variable, e is not one, it is a constant. Our last rule for today is the sum rule. The sum rule is like a buffet. You can differentiate each term separately. So, f of x equals g of x plus h of x. You can also write this as f prime of x equals g prime of x plus h prime of x. You can take the derivative of each all separately, as long as they're added or subtracted. For example, g of x equals 3x squared. H of x equals negative 4x. Here, we can take the derivative of them separately. For g of x, we'll use the power rule, and we get 6x. H of x, it's simple. There's only one variable, so we can just say that's negative 4. And a disclaimer, this only works when terms are added or subtracted from one another. Product rule and quotient rule are separate rules. Let's do some example problems. These will incorporate all three rules. f of x equals 2x cubed minus 5x squared plus x minus 7. What we first want to do is differentiate each term separately, since we know that they are all subtracted or added from each other. Our first term, 2x cubed, using the power rule, when we bring down the 3 and subtract 1 from the exponent, we get 6x squared. For our second term, we can use power rule again. We bring the 2 down and subtract 1 from the exponent, so we get negative 10x. The derivative of x is equal to 1, and negative 7 becomes 0 because negative 7 is a constant, and the derivative of a constant is always 0. So our final answer is f prime of x equals 6x squared minus 10x plus 1. Our next example is a little bit trickier. F of x equals 4 over x squared plus 3 rad x. This may look confusing, but it's actually pretty simple. What we first want to do is rewrite our terms. 4 over x squared, that's also equivalent to 4 times x to the power of negative 2. And 3 square root of x, that's the same as saying 3x to the power of 1/2. Once we rewrite our terms, it becomes very simple to differentiate. We can use the power rule for both. Bringing the negative 2 down, we get negative 2 times 4x to the power of negative 3, which is negative 8x to the power of negative 3. For our other term, we bring the 1/2 down, so we get 3 halves x to the power of 1/2 minus 1. This gets 3 halves x to the power of negative 1/2. And our final answer is f prime of x equals negative 8x to the power of negative 3 plus 3 halves x to the power of negative 1/2. Now we're ready to try some practice problems. Try these on your own and pause the video while you complete them. The answer for number 1 is 4x cubed minus 6x squared plus 5. We can get this answer by using the power rule for each term. First, for the first term, x to the power of 4, we bring down the 4 and subtract 1 from the exponent. 4x to the power of 4 minus 1, also known as 4x to the power of 3. We can use the power rule again in the next term. We bring the 3 down and we subtract 1. This gets us 6x squared. Our next term, 5x, the derivative of 5x is 5. We can just simply take the x away. And our negative 1 turns into 0 because the derivative of a constant is always 0. Number 2 might seem a little bit more difficult, but it becomes pretty simple once you realize that you have to rewrite the terms. First, we can rewrite 2 over rad x as 2x to the power of negative 1/2. The exponent is negative because the rad x was in the denominator. Plus 6 stays the same. We keep that as plus 6. Now knowing the sum rule, we can take the derivative of each term separately. For our first term, we'll bring the negative 1/2 down, which becomes negative x, and then we subtract 1 from the exponent. Negative 1/2 minus 2 over 2, that gets us negative 3 over 2. So our first term is negative x to the power of negative 3 over 2. For our second term, we know the derivative of a constant is always 0, so that just gets eliminated, leaving our final answer as f prime equals negative x to the power of negative 3 over 2. And that concludes our video on the basic differentiation rules, power, constant, and sum rules. Try the circuit worksheet I have linked below in the YouTube description. And thank you for watching.